So, good morning, Mr. Restu. My name is Warren and my friend Laura will present about ternary diagram. Next slide. The ternary diagram is the phase diagram of the system depicted on the plane in the form of equilateral triangle and describe the system three components of a substance in different phases. Number of phases that a three-component liquid system depends on the solubility of the substance, liquid, and test temperature. The purpose of the ternary diagram itself to provide an overview of the composition of the three variables with a plot on the graph of the two dimensions. This diagram helps integration of phase diagrams with how to describe the compositional regions of the different phases. The number of phases in the three components liquid systems depends on the mutual solubility in the liquid and the temperature. F is a degree of freedom. C is a number of components. B is the number of phases. 2 depends on the equation, depends on the temperature and the pressure because the two variables depends on the experiments. The keep phases rule applies to all matters, solid, liquid, or gas. For example, if the system there is a one phase, it is found that F is equal to, that is stating the state of the system. It is necessary to determine the concentration of the two components. Next slide. From the picture above, it appears that a pair mixtures partially dissolved. In the figure above, B and C are partially dissolved and certain pressure. If B and C are mixed into the ratio non-extreme, there is a two-layer are formed, namely B in C and C in B. The component A is a component that able to dissolve B and C. If component A is added, it will dissolve in both layers. As a result, the solubility of B and C increases because there is an interaction with the component A. The middle, in the type of two ternary diagrams. In the picture above, we can see the formation of two pairs partially mixed liquid. It means component A partially dissolved in component B. And the right side, in the picture above, the image type 3 of ternary diagram, you can see the scene of three components of the liquid, namely component A, component B, and component C. For the above component cannot be mutually dissolved perfectly. Next slide. The tools. 1. Breath to assist the titration process. 2. Picnometers. It is a tool to use to determine the density of a liquid. 3. Glass of thermometer is a tool to measuring the temperature as well as change in temperature. 4. Erlenmeyer become a container liquid chemical. 5. Beaker glass, a place to react material. 6. Measuring pipette to transferring liquids or solutions into container of various volume sizes. 7. Digital scales to measure the weight or load of mass or a substance. 8. Breath clamp, clamping the breath during titration processes. 9. Glass funnel, a tool to move or put a solution into a container. 10. Aqueous bottle to save the aqueous. 11. Filler to suck up solution that can be attached to a pipette base. 12. And the last is measuring glass to measure the volumes of a solution or liquid accurately. Next slide. There is three of the materials. The first is acetone, second is chloroform, and the three is aqueous. We can see above the bottle that acetone and chloroform is then dangerous. We can see the bottle, yeah. So we can use the MSDS material safety datasheet to help us to know about the solution. Next slide, my friend will be continue.
Okay, next I will explain about the procedure of this experiment. In this experiment, two stages of the experiment were carried out using an acetone chloroform mixture titrated with water and acetone water mixture titrated with chloroform. We do not use chloroform water mixtures because water and chloroform have a different polarity, so they cannot be dissolved. Okay, first we are going to make several mixtures of acetone and chloroform with a specific volume as much as 20 ml. And then we are going to titrate each mixture with water until the turbidity appears. Subsequently, we are going to do the same for the acetone water mixtures and titrate them with chloroform until the turbidity appears. This titration stage takes place 3 times in order to find the accurate volume that we have been used of water and chloroform. The appearance of this turbidity indicates that the mixture has been saturated. The turbidity of the solution is due to the different polarity between water, acetone, and chloroform. Successively, the polarity properties of water and chloroform are polar, semipolar, and nonpolar. When the mixture has reached its equilibrium, is allowed to stand, 2 layers will be formed, with the bottom layer being a solution of water and chloroform that partially dissolved, and a perfectly soluble solution at the top, which contains water and acetone. Acetone will bind hydrogen to water so that acetone and water can dissolve perfectly. After that, we will determine the specific gravity of each solution, which are acetone, chloroform, and water, using a pygnometer. Pygnometer by itself is a tool commonly used to find out the density of substance. At first, the empty pygnometer is weighed and standardized using a water to find out the actual volume of the pygnometer. The density of water used is the density of water at the room temperature. That's why we have to write down the room temperature during the experiment. Lastly, the titration results of chloroform acetone with water and chloroform and acetone water with chloroform were plotted based on percent mass and percent mole using a ternary diagram. Okay, the following curves are the results of the titration plot, where the left side is the percent mass and the right side is the percent mole, using a ternary diagram. On the curve, you can see the curved line form indicating the formation of 2 faces at the bottom of the dome. Even if the two have the same face, it's still called that have 2 faces because they do not mix with each other. The formation of these 2 faces occurs due to the chloroform and water that cannot be dissolved completely. Okay, to summarize our presentation, I will conclude the result of this experiment. So the mixture of acetone, chloroform, and water forms a type 1 solubility curve with the formation of a dome on chloroform and in a mixture of acetone, chloroform, and water. The formation of these 2 phases is caused by chloroform and water that cannot be dissolved completely due to the different polarity. Meanwhile, acetone and water, as well as acetone and chloroform, can dissolve perfectly due to the formation of hydrogen bonds between each component. Okay, that's all for our presentation today, and thank you for listening.